New Zealand's North Island is one of the most closely studied volcanic landscapes in the world. We probably know more about this volcanic zone than any other. There's not much of this region's physical geography that hasn't been investigated, measured and analysed. But we weren't always so well informed. Not that far back in time, it was a different story.
Until about 150 years ago, geologists still didn't have much of an idea how a volcano works. They called them burning mountains and thought that their heat came from coal and oil just beneath the ground.
The Maoris, though, the people who lived here in New Zealand before the Europeans arrived, were much closer to the truth. One of their legends said that a god burrowed at great speed through the ocean bed and broke through with terrific force onto the surface of the land. Since then, there have been any number of theories that try to get to grips with the major forces at work near the Earth's surface, the forces that have laid the foundations of our physical landscape.
The latest is the theory of plate tectonics.
From its middle to its edge, the Earth measures 6,400 kilometers. From the core all the way out to very close to the surface, temperatures are incredibly high, between 1,800 and 3,100 degrees centigrade. At this sort of heat, the rocks are mostly liquid. The outer skin, about 30 kilometers thick, is known as the crust, and this is what we live on. The plate tectonics theory, though, tells us to tear up the map of the world as we know it and start all over again. Forget the continents and oceans. What really counts is the division of the crust into 7 huge pieces that the theory calls plates. These plates behave like rafts on water. They are solid objects floating on the almost liquid rocks beneath. And just like rafts, they are on the move, ever so slowly, but they are definitely mobile. The next part of the theory picks up on that mobility. It says that some of the major features of the Earth's crust are related to the way the plates move in relation to one another. The theory identifies 4 main plate movements. The first is known as subduction. This is when one plate is disappearing beneath another. The second is called compression. This is when 2 plates are colliding head-on. It's also, for obvious reasons, one of the ways in which mountain ranges are formed. Next is extension, the complete opposite, when 2 plates are moving apart. This movement leads to the formation of huge ridges and depressions. The fourth is known as a transform boundary, 2 plates sliding past one another horizontally.
Like lots of processes happening in the physical landscape, these plate movements take place over extremely long periods of geological time. So much so that we are completely unaware of them. Occasionally, though, and it's always on the plate boundaries, something happens very quickly.
The friction between the plates generates such high levels of heat that the rocks melt and shatter. There is now a route open to the surface through the crust from the molten rocks beneath. The scene is set for one of the most dramatic events in nature.